Okay, so on the implicit review, looks like this. That was the answers. The first problem says xy squared. Let me make this bigger. Is that better? Can you guys see that? Yes. Okay, xy squared minus x to the third y equals 6. And the first part says show that dy dx equals that stuff. So what's the method? Dy dx is the derivative, so what's our method for finding the derivative for this problem? Implicit, yeah, implicit differentiation. And a lot of us got this one wrong on the quiz when we put like an x and a y next to each other. Some of you guys told me the derivative was just 2y, or was just 2. And how do you do the derivative of xy squared? It's a product rule. Like I'd say 2/3 of you did not do that on the quiz. You didn't make it a product rule. All right, so we have the first times the derivative of the second. What's the derivative of the second? 2y dy dx plus the second times the derivative of the first. What's the first one? 1 minus. And what do we do with this part? It's another product rule. So I'm going to put the product rule stuff in parentheses and I'll deal with the negative later. So I've got, or do you guys want to think of it as negative x to the third? Because we can do it either way.
Do it the way you're doing it.
Okay. Oh, perfect. All right. So the first times the derivative of the second. So there's my first one. What's the derivative of the second one? Dy dx plus the second y times the derivative of the first, and I'm dealing with the negative later. So 3x squared. All right. Equals, and what's the derivative of 6? 0. All right, what do we do with that stuff? Yeah, I like to simplify things. Some of you guys don't like to simplify things, and then you make little mistakes later. So on the test, please just simplify, waste all the paper you need. Oh, that's y squared. And yeah. Oh yeah, that's a minus. Thank you. So in case you missed it like I did, this negative should be distributing. So that should be minus 3x squared y. Thanks. Good catch.
Why do we always write xy?
Why do I always put it in alphabetical order? Is that it's just proper. It's not wrong if you don't, but it's more proper to have an alphabetical order. All right. What do we do next? Yeah, we need the dy dx's on one side and everything else on the other side. Do you guys have a preference about where they end up? dy dx on the left side. Okay, so I'm going to leave the 2xy over here then. And I'm going to leave the negative x to the third. And I'm going to move the y squared over, and I'm going to move the x squared y over. What do we do after that? Yeah, factor out the dy dx. And then divide the parentheses over. Okay, and then go ahead and check it. Is this the same as what's on the worksheet? Yeah. It's written a little bit differently, but is it equivalent? Yeah, it's equivalent. Okay, so that's got it. Part A is done. So part B says find all the points, that's a typo, all the points on the curve whose x-coordinate is 1, and write the equation for the tangent line. That's our favorite, right? We just love tangent lines. Okay, so that was part A. We want all the points where the x-coordinate is 1. So if I'm looking for the points where the x-coordinate is 1, should I plug 1 into the derivative, or should I plug 1 into the original problem? The original problem is where we get our points from. So I'm going to take the original problem, I'm going to put 1 in for x. Yeah. Now, if you plug 1 into the derivative, what is that going to give you? It's going to give you the slope. Yeah, so if you want the point, you got to plug it into the original. So I've got 1 times y squared minus 1 to the third times y equals 6. So we've got an equation to solve here. It's y squared minus y equals 6. How do you solve that equation? You square root both sides, right? You factor it. Anytime you've got a y squared and a y and a number, you have to factor it. That was good. What does it have to equal before you can factor it? 0. It's got to equal 0. So I've got y squared minus y minus 6 equals 0. What type of factoring is that? Or how do you factor that? Yeah, you do the x thing. So we're finding something that multiplies to negative 6 and adds to negative 1. Yeah, negative 3 and 2. So what are the factors? So y minus 3y plus 2. Those are the two factors, and then what are the solutions? 3 and negative 2. Okay. So there are 2 points that have an x-coordinate of 1. One of the points would be 1, 3. The other point is 1, negative 2. Okay. So the second part of B said to find the equation for the tangent line. How do we find the equation for the tangent line at those points? So plug it into the derivative. Are we only plugging in x equals 1? No. We're going to have to plug in the x and the y. That means we're going to have to evaluate the derivative twice. Once where the x is 1 and the y is 3, and then a second time when the x is 1 and the y is negative 2. So you have to do it twice. All right. So I'll go ahead and evaluate it. And a notation that you can use to show how what you're plugging in is you can say dy dx evaluated at 1, 3. That means I'm plugging in x equals 1 and y equals 3. So I've got negative of 3 squared plus 3 times 1 squared times 3. And 2 times 1 times 3 minus 1 to the third. It's minus x to the third. So it's not negative 1 to the third, it's just 1 to the third, but you're subtracting it. Yeah. I scanned this answer key already and I just found a mistake. All right, did you guys get the same slopes? So we got a slope of 0 and a slope of 2. Is that right? Is that what you got? Okay. So for the point 1, 3, we have a slope of 0. For the point 1, negative 2, we have a slope of 2. So if that's the information you have, how do you write the tangent line? So y minus 3 equals 0, right? Because that's the slope, so 0. Well, yeah, we have to write the equation of 2 different tangent lines, yeah. So y minus 3 equals 0 times x minus 1, that's the first one, and then what's the second one? So there's your 2 tangent lines. Okay. Part C is kind of tricky. Yeah. Are you gonna go around the school again, and then we're gonna find your notebook in your backpack. Kind of like how you checked for your phone 3 times.
I didn't even check my bag.
Okay, you can go look for it. All right, part 3. Are you guys ready? So if you look at part 3, it says find the x-coordinate for each point on the curve where the tangent line is vertical. So if we're looking, yeah, what is 0? 0's on the bottom. Does that make sense? How did he know 0 would be on the bottom?
Because it's undefined.
Yeah, because it's undefined. So if you have a slope that's undefined, then you should have 0 on the bottom. Right?
Yeah.
Okay. On the bottom of what? Can someone else tell me, someone other than Patrick? What are we looking at the bottom of? Which equation? The derivative. So the derivative is how we find all of the slopes. If we're talking about a vertical tangent line, so our slope is going to be undefined, we got to have a 0 on the bottom. So if you go back up to your derivative, we're going to take the bottom of the fraction and set it equal to 0. And that's how we're going to find those points. All right. What's the problem that you feel like you're going to run into? There's a y and an x. Okay. So what do we do? Because we are taking the derivative and we are finding a vertical tangent line, but we're finding a point that makes a vertical tangent line. And would that point be from the derivative or would that point be from the original equation? It would be from the original. So what we're about to do is we're about to do some sort of solving here, and we're going to plug it back into the original equation to help us find the rest of our answer, because the point comes from the original equation. Okay. What sort of solving could we do? You could try to get y by itself or get x by itself. Which one do you think is easier to get alone? probably the y. So we're going to get the y all by itself. All right? So I'm going to say 2xy equals x to the third. And how do I get y all by itself? Yeah, divide by 2x. So y equals, can I simplify that a little bit? Yeah, so I can get rid of one x on top and the x on the bottom. So y equals x squared over 2. And what do you guys think we're going to do with that if we need the answer from the... Yeah, plug it in for y in the original equation. Yeah, you ready for it? I know, it's a good time. It's a good time, right? This is enjoyable? We're enjoying this math problem? This worksheet takes a minute. It takes a little while.
A minute. The whole page. A minute.
It took us a minute for this problem.
Yeah. All right. It took us 16 minutes and 27 seconds. We're not done yet. All right, so let's go back to the original. We've got x multiplied by y squared, and instead of writing y squared, I'm going to put x squared over 2 squared. Oh, look at you. That's quick. That wasn't even the whole period. All right, minus x to the third times y equals 6. But aren't you glad I didn't leave this for you to do tomorrow?
Yeah.
See, I got you guys. I got you. Yeah. Okay. We're going to keep going. What do we do next?
You got to do the square.
So what does this squared on the outside do to the inside of these parentheses? So the x is going to stay in the front. We're going to have x to the fourth over 4. How about this part over here? How do I multiply x to the third times x squared over 2? It's x to the fifth over 2. If it makes you feel better, I put x to the 6th and I got the problem wrong and I had to sit there and think about it for a really long time. Yeah, the bases are the same, so you add the exponents. Yep. Okay. We can do a little bit more simplifying. What can I do with this part right here? X to the fifth over 4 minus x to the fifth over 2 equals 6. Yeah, I wouldn't multiply by 2. What would you multiply by? Because we want to get rid of the fractions, right? Multiplying by 2 would only get rid of this fraction.
X over 2. Or x over x. I don't know.
You could multiply by 8. That'd be a little bit bigger than it needs to. You can multiply by 4, because 4 would get rid of the 2, and it would get rid of the 4. Yeah. So we can multiply the entire equation by 4, get rid of that fraction. Are you guys having fun yet? Woo. Perfect. Perfect. So if you distribute the 4 to the first part, what do you get? X to the fifth. If you distribute 4 to the second part, what do you get? Yeah, so minus 2 x to the fifth equals, not 6, 24. You gotta distribute the 4. Okay.
But it's not 4 x to the 5th.
No, because the 4 is canceled. The 4 that you were multiplying and the 4 on the bottom canceled. Okay, you guys, we are almost done solving for this x. 20 minutes later. X to the fifth minus 2x to the fifth would be what? Negative 1, because you have 1 and you're taking away 2, right? 1 minus 2 is negative 1. So I said this is like a 1x to the fifth, and we're subtracting 2, so it'd be negative 1x to the fifth. And then what do we do? Divide the negative over, right? So x to the fifth equals negative 24. And how do we get rid of the exponent of 5? Fifth root, yeah. No, that was it. That was it. So the problem only said find the x coordinate, not the whole point, just the x coordinate.
Oh my God.
So we found that.
Yeah. Then we would. What if it asked for the other point?
If
You have
it-
to go back and plug that in.
If it asked for the y coordinate, if it asked for the whole point, you'd go back and plug that in.
You would go back and do what?
So number 1 is done.
So you plug this back into this.
If you needed to find the whole point, you would take this x value and plug it into the original equation and solve for y. Yeah. So this worksheet will take you approximately 2 hours.
Great.
I'm just kidding.
No, you're not. You're not actually.
Okay. wait. Don't be upset. Go ahead and try, because these problems are very repetitive. They're just asking you to find very similar things repeatedly. That's what repetitive means. Go ahead and try number 2. So number 2, part A, it's just you verifying the answer again. We're going to pause, James. Yeah.
Well, why couldn't you just subtract x, y first?
You could have. Yeah, that's fine.
They were asking me to do the original.
I think I'm on that one too.
No, you're watching this on my phone like 21
All right, are you guys ready to talk about part B? Some of you guys have tried it, and there's 2 different approaches, and I'm going to explain my approach, and then I'm going to explain Miles' approach, because his approach was way better than mine. Okay? So, part B. You guys are like, I'm going to ignore her until we know Miles' approach. Okay, so, part B. Hey guys, let me explain to everyone. All right, so part B says, show that there is a point P. So we're going to say point P equals, and it's a point, it has an x-coordinate of 3, and it says that the line tangent to the curve is horizontal. So the tangent line is horizontal. What does that mean? Slope of 0. So horizontal tangent line means that m is 0, and we always get our slope from our derivative. All right, so my method of doing this problem is I was focused on the part where we have a point there, and I took the x equals 3 and I went back to the original equation and I plugged x equals 3 up here so that I could find my y coordinates. And you end up finding that there's 2 different points that have an x value of 3. That was my method. And then once I had done that, I treated it like problem number 1. Once I had found those 2 points, I went back and I plugged both of them into the derivative to see which one made the derivative equal 0. Miles had a different method. Miles said, well, I know that the derivative should equal 0 because it's a slope, it's a horizontal tangent line. And so what would he do to set the derivative equal to 0, to make sure this equals 0? What do you have to do? Just make the top equal 0, that's it. So he took the top and he wrote negative 2x plus 3y equals 0. And then what number do we already know that we should be plugging in? 3, because they told us that of the point, the x coordinate is 3. We already know that. So now you can go ahead and plug in 3 for x. So we've got negative 6 plus 3y equals 0. So 3y equals 6. And so what is the y coordinate of that point? 2. And if you did all the work to find the 2 points, now you're mad about it.
Yeah, pretty mad.
So if you look at my answer key, you'll be happy to see me walk through the problem, finding both the points with you. I did all the work also. So there are usually multiple like entry points to a problem. There's different ways to go about doing it depending on how you thought of it.
I'm gonna get the right answer.
So, all right, now part C says find d2y dx2 for the point that you just found. So what are they asking us to do? They're asking you to find the second derivative, right? So, how am I going to find the derivative of this? Just do a derivative. It's a quotient rule, right? Okay. Go ahead and work on it. So 2 part C, you're doing the quotient rule. I froze it so you can't see it, but I'm going to keep going.
That's evil.
I know.
Which one did you?
How many of these are you going to hold to?
Not a lot.
That's a lot. That's a lot more than 2. You're more than 2 is too many.
No. Huh? Gonna be honest, I haven't typed it up yet. Did you liked the quiz though? You want it to be like the quiz?
So is it low, D, high, high, low?
It's low, D, high. Yeah.
Do I have to do all that? Like foil it out like this? That's what I did, and I feel like I did too much.
You don't need to do all this because it's asking you to evaluate it. It's just asking you to plug in 3, 2.
So I just plug in 3, 2 instead.
Yeah, so I would plug. So you already plugged. You already know what dy dx is. If you already know it's 0, so you can just plug in 3 for this y here and 2 for this x here, and when you hit dy dx, you're just going to put 0.
Plug this in. Oh, plug in 0. Ha ha ha. Okay, thank you.
All right, so we have this mess, right? This is kind of a mess, and we do not have to simplify it. Why do we not have to simplify it? No, not at all. Because you're evaluating it. You're plugging in. Yeah, you're plugging in the point. So you're plugging in 3.
I did it too.
Yeah, a few people did. You're plugging in 3 for x. You're plugging in 3 for x and 2 for y. And can somebody remind me what dy dx equals? What does the derivative equal at that point?
0.
It's 0, right? The slope is 0 at that point. So anywhere you see dy dx, you just plug 0 in. Okay? All right? So you can so you're going to take the y and plug in 2. So we have 8 times 2 is 16. 3 times 3 is 9. Negative 2 plus 3 times 0 is 0, right? 3 times 0 is 0. Minus negative 2 times 3 is negative 6. 3 times 2 is positive 6. 8 times 0 is 0. Minus 3. Divided by 8 times 2 is 16. 3 times 3 is 9 squared. So it's not as bad as it looked. It looked really bad, but it's not too terrible.
pretty bad.
I mean, it's still pretty bad, but. All right. 16 minus 9. 7. So we got 7 times negative 2. And what is negative 6 plus 6? 0. So over here we've got 0 times negative 3. I'm not even going to write that down because that's just nothing. Right? This, you don't even have to worry about it because this is 0 and this wipes out that stuff.
Okay.
Yeah, so no need to even worry about it. And then on the bottom we got 7 squared. And you can multiply and then simplify it if you want. I went ahead and said, oh, 7 on the top and one of the 7s on the bottom should cancel. And so you get negative 2/7. So isn't that fun? Oh man.
Fun at all, actually.
Isn't that fun? So you can skip number 5 on that page. The reason I'm only having you skip number 5 is because on the test, there are 2 questions that are similar to this worksheet. 2, where they have the different parts. First, prove that this is your derivative. Second, do this thing with it. Okay? So make sure that you understand if it says vertical tangent line, what that means for our derivative. That means we're going to take the denominator of our derivative and set it equal to 0 and find out where that happens. If it says horizontal tangent line, that means we're taking the top of our derivative and setting it equal to 0 and finding those points. Make sure you can do that.
Wait, so Ms. Price, if this is find all points x around the curve where the line tangents to the curve is like a 1/2, would you have to find the derivative?
So you want the derivative because that's where the slope comes from. So you take your derivative and you'd set your derivative equal to 1/2.
So y over 2y minus x equals 1/2 and solve that?
Yeah, and what I did, since you have a fraction equals 1/2, is I cross multiplied.
Okay, yeah, that would
And then
yeah.
So, your last test told me that the table might need to be reapproached again. Reviewed. We might need to review the table. I struggled for that. All right. It did. It took me a little bit. Okay. Now, what I will say that I liked about this worksheet is the chart, I'm going to be honest, is not on the test. So we are going to talk about a couple of those because I think that the ideas behind the chart are still good because the types of derivatives you use the chart for are still going to be on the test. But I liked this worksheet because it had some more problems on it. Like after you get past the chart ones, there's just some other derivatives that I think are good practice and are good to find, which is why I left the worksheet for you to do. So I do want to talk about a couple of these because I think some of us forgot or just didn't really understand how to use the chart. And I want to make sure that we do because there's a very real chance that it could be on the AP exam. So we've got more to worry about than just whether or not it's on the test for us. We just want to make sure we can do these. So let's go ahead and write down the first one. When it says d dx like that, what does d dx mean? Yeah, it means find the derivative of this stuff. So d dx means I'm finding the derivative of f squared of x minus 3g of x squared at x equals 1. And I think that the way this is written is very confusing. Well, not very confusing, but a little bit confusing. I'm going to go ahead and fix the way this is written. So I'm going to say this is f of x and that function itself is being squared. So it's kind of like if you said sine x squared or sine squared x, this is what you actually mean. So the whole function is being squared. That's what that notation means. Minus 3 times g of x squared. So how do we find the derivative of f of x to the second power? Yeah, it's a chain rule. So you're going to take the 2 and bring it to the front, but the inside is going to stay the same at first. So bring the 2 to the front, and then your exponent drops by 1. And we're going to multiply that by, and now we're doing the chain rule part, the derivative of f of x. So f prime of x. So I took the derivative of the outside, which was me bringing the 2 to the front and dropping the exponent by 1, and then I multiplied by the derivative of the inside. Does that make sense for that one? Okay. And then over here, how do I take the derivative of negative 3g of x squared? Yeah, it's the constant multiple, so the negative 3 is just going to stay, right? And then the outside function is g of x. The inside function is that I've got an x squared here. So how do we take the derivative of g? Yeah, g, it's going to be just g prime, right? And the inside is going to stay the same to start with. And then we're going to multiply by the derivative of the inside, which is 2x. So the reason that these problems are good problems is because they really get to the core of, do you understand how the rules work in a situation where it's not like a function that you've seen before? Like, most of us don't consider functions this way, but we're trying to make sure that we understand how the rules work, and these problems really get at that. Like, can you do the rules? So we had constant multiple, we had a chain rule in there, we had some exponents, so lots of stuff going on. At this point, it says x equals 1, so now we can just go through and evaluate this. So 2 is being multiplied by f of 1, and then can you guys look at the table and tell me what f of 1 is? It's just 1. So at the beginning we've got 2 multiplied by 1, and this is being multiplied by f prime of 1. What is f prime of 1? 3, so times 3. Minus 3 times g prime of 1 squared. So minus 3 times, what is g prime of 1 squared? It would be negative 1, yep. And then on the end we have 2 times 1, which is 2. So we've got 6 plus 6. Is that what you guys got? 6 plus 6?
Yeah.
So I literally just plugged 1 in for the x, and I said 2 times 1 is 2.
I think it's negative 12 because I think 12 is not negative 12, but I think the g prime is negative 1.
So g prime of 1 squared is just g of 1, and g prime of 1 itself is negative 1, and you don't square it because it's not saying to square the derivative, yeah. Okay, so it is 12. Alright, does that make sense? A little bit? Okay, let's try number 3. So that was number 1. We're going to try number 3. So, what type of rule are you using for number 3? It's not a product rule. It's a chain rule, yeah. So it's not saying, you're not taking one function and multiplying it by the other. G of x has been plugged into f of x, so it's a composition, it's a chain rule. You have an inside function and you have an outside function. So how are we going to do the chain rule on this? So how do we do chain rule? We do the derivative of the outside, so we're going to say the derivative of the outside where the inside is the same times the derivative of the inside. And number 3 said when x equals 1. So my first step is going to be to figure out what g of 1 is. What's g of 1? Negative 2, okay. So that means that I'm actually finding f prime of negative 2. What is f prime of negative 2? It's negative 5, good. And then over here we're just plugging the 1 in, so g prime of 1 is negative 1. So we're going to take this and multiply it by negative 1. And so what should we get? 5.